Okay, what if we have a polynomial with imaginary roots? Right, because we can't draw imaginary numbers on a number line. Well, since when we're working with inequalities, we always work with real numbers. Inequalities don't even make sense for complex numbers. When we want to go to working with only real numbers, we use the corresponding irreducible quadratic factor. When we have an irreducible quadratic, like that one for example, then that factor is never 0 when x is a real number. That's the point. That's what makes it an irreducible quadratic. It doesn't have any real zeros. Instead, it's either always positive or always negative. To know which of positive or negative it's going to be, we use the fact that if the x squared term is positive, it's always positive. If the x squared term is negative, it's always negative. The sign matches the sign of the leading term. Okay, so how do we handle this? Here we have a polynomial with an irreducible quadratic factor. To confirm that that is an irreducible quadratic, and also to think more about why its sign is what it is, let's do a little bit of analysis on this by completing the square. So we have drawing a square over here, and x squared, split the minus 4x in half. So then we'll have x times x, each of those times a minus 2. We need a plus 4. So that's x squared minus 4x, while 7 is 4 plus 3. So we have x minus 2 squared plus 3. And then, since this can't be negative, this whole thing is always greater than or equal to 3. It's always positive. What about the other two factors? Well, x minus 4 is 0. That means that x is 4. 2x plus 1 equals 0. That means x is negative a half. So our cutoff points are negative a half and 4. With the x minus 4 factor being 0 here, the 2x plus 1 factor being 0 here, and our irreducible quadratic factor being positive everywhere. It's positive everywhere. It's not really going to have much effect on our sign analysis, but we need to know that it's there. So x minus 4 is negative when x is a small number. It's positive when x is a big number. 2x plus 1, also negative when x is a small number, and positive when x is a big number. So our product is 0 at our two cutoff points. It's positive to the left of negative a half, negative in between, and positive to the right of 4. We're looking for greater than 0, so we don't want to include our zeros. We do want to include the parts where the product is positive. So our solution set is going to be negative infinity up to negative a half, which is not included, union 4 up to infinity.